video. It says chapter 9. You can just disregard that. It's a quick video on chemical quantities. What we're working with is limiting an excess reactant. So I'll do this first one with you. Maybe I'll do the second one. Ethane gas, C2H6. It's going to react with oxygen gas. Hopefully you remember that oxygen is diatomic, so it's O2. When it reacts, this is a combustion reaction. So the products, if you hopefully remember, are CO2 and H2O. We have to balance this. So when we balance it, there are 2 carbons on this side, so we need 2 carbons on that side. There are 6 hydrogens on the left-hand side, so we will need 6 hydrogens on the right-hand side. Now let's look at our oxygens. 2 oxygens on the left. We have 2 times 2, we have 4 oxygens on the right, plus 3, we have 7 oxygens on the right. So how do we get 7 oxygens on the left? We multiply this times 3.5. Alright, now you know that you can't have a decimal for the oxygen, so you know you have to double everything. So what you're going to do, so you're going to say this is a 2, this is a 7, this is a 4, and this is a 6. Alright, and then when you have those numbers there, you'll be able to say, okay, look, I have 4 carbons here, 4 carbons there, 12 hydrogens, 14 oxygens, 8 plus 6 is 14 oxygens, and we're all set. There's a plus sign right there. We'll just erase this little guy right here. Alright, make everything look good. Alright, that's how we balance it. Now, after it's balanced, the amount of the reactants are 20 grams of ethane and 20 grams of oxygen. Oxygen weighs 32 grams per mole. Look at the periodic table if you don't believe me. 16 plus 16, 32. Ethane weighs 2 times 12 is 24 plus 6. Ethane weighs 30 grams per mole. Alright, so what are we going to do? We're going to say we are going to start with our given. And what were we given? Excuse me, I'm looking for that. I was given 20 grams of ethane and I was given 20 grams of oxygen. And that's what I'm going to start with. I'm going to start with those. So here's my 20.0 grams of C2H6. I'm going to convert this into moles because I can go from grams to moles. Moles is my middleman. So 1 mole of C2H6, and that is going to be over a certain amount of grams, and I already told you it weighs 2 times 24 plus 30 grams per mole. Alright, then I want to see how many moles of one of my products I can form. I'll just pick a product. Let's pick carbon dioxide this time. So let's say we have 4 moles of carbon dioxide for every 2 moles of C2H6. Alright, and then I'll be done. I could convert into grams, but I don't need to convert into grams for right now. So 20, I'll just have my calculator here. 20 divided by 30, alright, times 4 divided by 2 gives me 1.33 moles of CO2. That's how much CO2 I could produce if I had 20 grams of C2H6. Let's see how much CO2 I could produce with 20 grams of oxygen. Let's check that out. 20 grams of oxygen, 1 mole of O2 is 32 grams for every 1 mole, times 4 moles of CO2 for every 7 moles of oxygen. Where did I get this 4 and this 7 and this 4 and this 2? I got the 4 from right here. There's my 4. Alright, 4 CO2s. 4 moles of CO2 for every 2 moles of C2H6. 4 moles of CO2 for every 7 moles of oxygen. When I do that math, 20 divided by 32 times 4 divided by 7, I get 0.357 moles of CO2. Therefore, this here, this guy here, that's my limiting reactant. Okay? Limiting reactant right here. What is this then? This is my excess reactant. Why is it excess? Because if I used up all of the ethane, all the C2H6, I'd be able to produce 1.33 moles of CO2. That never happens. You know why it never happens? Because I run out my limiting reactant, my limiting reactant, which is my oxygen, runs out first. How do I know that? I know that because the oxygen I have, the 20 grams of it, only allows me to produce 0.357 moles of oxygen. Therefore, this is my theoretical yield. All right, let's scroll down a little bit. Let's see what else we got going on here. Given the amounts of the reactants, what is the theoretical yield of each product? You could do each product. I figured out the limiting. So I could get 0.357 moles of the CO2, and if I wanted to find the moles of the other product being the water here is in a 6:7 ratio to the oxygen. So all I got to do is this. I go 20 grams of oxygen times 1 mole of oxygen for 32 grams times 6 moles of water for every 7 moles of oxygen. And I would do that math, and it's 20 divided by 32 times 6 divided by 7, and I would get 0.536 moles of H2O. That is the theoretical yield of each one of the products. Okay, I got this number from here, and I got that number from there. The amount of excess reagent, given the amount that we had in the first problem. Now, how much of the ethane are we going to have left over? Look back up here. The ethane is the excess reactant or reagent, whatever one you want to call it, they're synonymous. How much of that 20 grams are you going to have left over? Here's how you do it. You start with your limiting reactant, the oxygen. So I say, okay, change colors here. If I have 20 grams of oxygen, how many moles do I have? 1 mole of O2 for every 32 grams. Then what I'm going to do is I'm going